Hello friends, let us move on the last video of our unit 3, that is the problem on the evaluation of the stiffness matrix for the CST. So let us take the problem, that is this the element is given, and their coordinates also given. So I is given 0 and -1, j is equal to 2 and 1, and m is equal to, that is 0 and 1. These are the xy coordinates. Okay, why this one is the xy coordinates? Because this one are not within the range of a 1 only. Here this one is the 2. So this one are the xy coordinate, not the xi eta coordinates. And what they have given, just they have mentioned that just evaluate the k as well as the stress, that is the stress. So, or the principal plane and the principal stresses also they are asking to calculate this one. Here they have given the coordinates are given and assume the plane stress condition. They have not, they have mentioned that is the plane stress. So ultimately my D matrix is, I need to calculate, constitute D matrix I need to calculate as per the condition of the plane stress matrix, not the plane strain conditions. Values of E and A also given. The values of this Poisson's ratio, that is V is equal to 0.25, thickness is given, and assume the nodal displacement have been determined to U is equal to 0, 0. So this one is the U nodal displacement. So at this one there is a nodal displacement along U and along V. So this one is the UI is given, and VI is also given. So there is the, sometimes the problem is written in a short form, sometimes the problem is given in a very huge form. Till date there is no problem is asking, but there is a possibility they may ask the question this year also. So what, how to calculate? So the U values are given, V value is given, U2, V2, all these values are given. Now we know the element stiffness matrix. K is equal to beta transpose into D matrix into B matrix into T into A. Now T is given, A is given, B D, that is the constitute D matrix is related with my V values, that is the Poisson's ratio, so that can be very easily finding. Now the issue is related with only, that is the B matrix calculation. So beta matrix is equal to, this beta matrix is equal to beta I, beta j, beta m. Similar way gamma I, gamma j, gamma j. Hence my beta matrix I can calculate very easily. Beta matrix is equal to yj minus ym. Bj is equal to, that is this term is not included into that, that is the ym minus yi, and bm is equal to I minus j. So if I looks towards this one, that is the beta I is equal to gamma j, gamma m, then gamma j. So next term, that is the ij m. So m minus I and m, that is I minus j. So put the values of the yj. Now what is mean by the yj and ym? So yj and ym, so yj, this is the yj, so where is the j? This is the y. So this one is the values of x and y, so yj, so this is yj minus ym, so this one is the minus ym. So go for this 0 minus 1. So here see 0 minus 1. So this one is the minus 1. Similar way this one is to be considered. Similar way this one is also considered. So Bi, Bj and Bm is calculating by using these formulas. Same way Yi and Yj and Ym also calculated by using these formulas Xi, Xj and all these one, because this one is Y, beta is along J, Y coordinate, and beta is gamma is along X coordinate. So according to that I am able to calculate these calculations. Hence my beta matrix is equal to that one is equal to 1 upon 2a. This one is the, this one is my n1. So n1, n2, or directly we can say this one is the beta I, beta j, and beta m, beta j. Then this one is the gamma j, and gamma m, and these one are according to that values I need to put here, so that this is my beta matrix. This is my beta matrix. Then this one is my constitute D matrix. This D matrix I need to write in terms of my Poisson's ratio. So E upon 1 minus V square multiplied by this matrix, that is 1 minus V 0 V minus 1 0 0 0 1 minus V upon 2. This is the constitute matrix D matrix for the plane stress condition. So this B matrix is calculated, D matrix is calculated. Now my K matrix is very easily calculating. K is equal to E upon this value 2A multiplied by B transpose. So whatever this matrix I am calculating, this value, that is the B matrix, the transpose of this one, the transpose of this one I am putting here, the transpose of this one, transpose of this one, then multiplied by D matrix multiplied by my B matrix. So by solving this one, I am getting this equation. By getting this equation, now calculating these things are very difficult issue. That's why in an examination they are reluctant to ask the any problem upon on this one. They are generally focusing on the theory, hence I am focusing on the theory in a right way. Now let us move on calculation of the stress matrix. So stress matrix is equal to D matrix B matrix into D matrix. So D matrix we are already calculating, D matrix already calculated, then the B matrix also calculated, multiplied by my D matrix. So D is given into the examination. Hence after a triple manipulation of the matrices, I am getting the sigma x is equal to sigma y is equal to and the tau xy is equal to. Hence my principal stresses is equal to that these values addition of the sigma x plus sigma y divided by 2. Then this is the principal stress value. Then then the sigma minimum is also calculating, and the sigma, that angle, that is the principal stress angle or the principal angle, is also calculating very easily. So that just for the understanding point of view I have taken this problem, but you will try to go through that one and check that how to solve the matrices, because when we are solving the matrices a lot, then and only then we could be able to solve the problem. So focus on the matrices, do the study of a matrices, and be comfortable with the problem. So with this video we are concluding the unit number 3. Thank you to all.